Which brings us to this question, which is if you're only using lowercase letters, how long should it be to survive a brute force hack? If you just use lowercase letters, so no numbers, no uppercase, no special characters like the % sign or the exclamation mark or anything like that, how long should it be to survive a brute force attack? Okay, so please press pause and try it yourself. What we're going to do is try to find a password long enough with lowercase letters to where there are at least this many combinations of it. And that way, it'll take our typical hacker more than a year to guess the password with their program. Okay? So, I hope you press pause and tried it yourself. I'm going to go through it now. And just to try to, oh, for goodness sakes, just to try to break it down a little bit. Look, imagine, okay, we know there's 26 lowercase letters in the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, Z, right? We know that there's 26 of them, right? But I'm just going to do this really simple example. Imagine we're only using, let's see, A, B, C, let's say we just used ABC, and let's say it was just a two, the password was 2 letters long, okay? Just to get an idea for what's going on here, in case you're lost and you think we're making all this up. But it would look like this. Your password could be A, it could be AB, it could be AC, right? Or that's all the possibilities starting with A. Then list the possibilities starting with B. It could be what? If your password, and so I'm just trying to break this down to something simple. Imagine we just said these 3 letters and it was just two letters long and that's it. How many combinations are there, right? So there are, all this is beginning with A. So beginning with B, we could have B what? B A. We could have B B, and what else? BC. So there's some more passwords with just these letters and just two letters long, right? So how about all the passwords beginning with C? You could have CA, CB, and what else? CC, right? Now that's how many passwords altogether? AA, that's one password, that's another one, that's another one. So how many combinations did we get? All right, I see 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And the reason for that is, and one way to think about it is, there are three possible numbers of letters, possible types of letters that could be put in the first box, let's say, for the first character, right? And then there's 3 that could have been put in the other one. And if you go 3 times 3, what do you get? 3 times 3 is 9, right? So what we found is, if we're just using an alphabet that only has 3 letters in it, A, B, C, okay, and our password is only 2 letters long, that's 3 to the power of 2. And that's how you'd figure out the number of combinations, 9, right? So just on that then, what if we had a 1-letter password, but we're using all the letters in the alphabet? That means that our password can be either A, B, C, D, or all the way to X, Y, Z, right? How many possible passwords if it's just 1? Just 1 letter, the amount of possible passwords is 26, okay? Now, if you want to have it at 2, with 2 letters long, and you're using all of the lowercase letters of the alphabet, how many possible passwords can we create now? Okay? So in this first box, you can have A and ABC, any of these, but in the next box, you can have any of these 26 letters as well. So in other words, you can have AA, AB, AC, AD, all the way until AXYZ, right? Or you can have BA, BC, BD, BB, I forgot, BC, BD, all the way to BZ. Or you can have CA, CB, CC, all the way to CZ. And on and on and on until you get to Z, or ZA, ZB, ZC. This is difficult for an Irishman to pronounce Z's instead of Z's. ZZ. I mean ZZ, right? So, how many passwords can we make up if we're using all the lowercase letters of the alphabet and our password is only 2 letters long? Now, if you get this, you should be able to get, you know, the basic concept and solve the whole problem, hopefully. So you kind of think there's these boxes, right? So there's 26 possible letters here and 26 possible here, and it's 26 times 26. And if this was done out to be like a big, if you wrote them all out, you'd have 26 on this column, right? And 26 on this row. So it's 26, you'd have 26 here, right? And you would have 26 here along that way. So there's actually 26 times 26 passwords. I'm just plugging that in, 26 times 26, which by the way, I hope we know was 26 to the power of 2, 676, okay? So if it was just 2 letters long, there'd be 676 combinations, right? Let's see. 676. Okay, so our question though is like, how long should our lowercase password be to be safe in the year 2021? That's what we really want to know, right? So to figure that out, you can just press pause at any point and try to get to the end. I'm just going to walk through for anyone that's still struggling with this, right? So to explain it further, so imagine if so here's our first digit, our first letter. There's 26 possible there. And our second letter, there's 26 possible there. Our third letter, there's 26 possible there. So for if it's 3 letters long, it's 26 times 26 times 26, or 26 to the power of 3, right? If it's 4 letters long, okay, how many combinations are there if you've got 4 letters in it, right? Well, that'd be 26 to the power of 4, and so on, right? So just use your calculator and guess. That's all I'm asking you to do. So like just go, okay, 26 to the power of 4, well, that's about 500,000, okay? So, well, that's a lot of combinations, but hey, it's not close to our big number here that we're looking for. We're looking for 3 quintillion. 3 quintillion. That's what we're looking for, okay? Tillion, right? So not even close. Let's try more letters, right? If you had 5 letters in this password, it'd be 26 to the power of 5. Still not close to this massive number that we're looking for, are we? Right? Not good enough. So what should we try now? 26 to the power of what? Should we go big? How about 10? Ooh, that's getting somewhere. That's 1.4 times 10 to the power of 14. Now, is that more than this number or less? Yeah, so we're still less, so we're not there yet. But 10 is good. 10 is good. By the way, it's not good enough. How about 11? Now we got 3.6. It's about 4 times 10 to the power of 15. Is that bigger than this number? Still not bigger, not good enough. Let's try 12. I got almost 10 times 10 to the power of 16. Still not there. And I'm going to try 13 letters long. We're getting close now. Look at that. About 2.5 times 10 to the power of 18. Which, by the way, is that... Okay, I'm just going to write that one down because that one got close. Okay. So when we had 13 of these lowercase letters, it was about 2.5 times 10 to the power of 18 possible combinations, right? Okay, and so that is that more than this number though? Because we want our password with the lowercase letters to be more than 3 quintillion, all right? So it's a little bit less. So what should we try now? Should we try 14 letters? Okay, and that would be 26 to the power of 14. Plus 26 to the power of 14, right? So 6 about times 10 to the power of 19, okay? Or about 6.5 or so. So if we've got 14 letters in our password, that gets us to about 6.5 times 10 to the power of 19 combinations, which is above our standard for safety that we've established. All right. And so, yeah, 14. So let's make one up. And don't give your name. Don't give your dog's name. Don't be putting in like common words like, you know, you want to be making this hard to guess as well. So, but in any case, let's see. Can I even, is there any such a thing? I don't know. Let's see. Dragon. Swims in the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I guess I got, did I get more? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 in the ice cream or something. Dragon swims in the ice cream. Oh, that's not bad. That's like way over 14. And actual fact, the problem with the lowercase letters, everybody, is I'm not sure if that's even that safe, because the hackers are probably going to guess pieces of words, you know, in their algorithm anyway. They're not just guessing like one letter at a time. So if you want a 14-letter password that's actually safe, and by the way, this is more than 14. I just made that one up, and that is like probably safe. I'm not 100% sure. But a 14-letter password with lowercase is actually safe would be something like this. X, I, R, S, T, U, U, V, W, A, B, C. That's what we got. The 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, now that is a safe 14-letter password, because there's actually no proper word in there or anything. So anyway, but yeah, let's watch a fun video on how we should really be shifting our thinking from passwords to passphrases. Okay, so because the hackers are getting so good, like one word password not good enough. You need a passphrase. So let's just pause and just have a look at this concept.